Everyone, in this video I am going to explain IUPAC nomenclature of organic compound. It takes some series of videos. In this first video, IUPAC nomenclature according to IUPAC. What is IUPAC? International Union of Pure and Applied Chemistry. International Union of Pure and Applied Chemistry. So, it's an union which propose some rules to name organic molecules, to name different organic molecules. They were proposed some rules. So in this session we are going to discuss the structure, IUPAC structure of organic molecule and rules followed by rules like that. Okay, what is IUPAC first? IUPAC abbreviation, IUPAC is International Union of Pure and Applied Chemistry. International Union of Pure and Applied Chemistry, shortly IUPAC. International Union of Pure Applied Chemistry, IUPAC. So as per IUPAC, the name of organic compound contain 2 to 5 parts. Some organic compound contain 2, some contain 3, some contain 4 parts, some contain even 5 parts. So the name of organic compound contain 2 to 5 parts. They are root word, primary prefix, secondary prefix, primary suffix and secondary suffix. So according to IUPAC according to IUPAC name of organic compound, IUPAC name of organic compound contain organic compounds contain 2 to 5 parts. 2 to 5 parts. They are root word, primary suffix, primary prefix, secondary suffix and secondary prefix. The structure is like this. So first root word, for every organic compound there must be a root word plus primary suffix. Each and every organic compound IUPAC name contain root word and primary suffix. Along with root word and primary suffix, some organic compounds may contain secondary suffix. Some organic compounds contain primary prefix. Some organic compound contain secondary prefix. So each and every organic compound contain root word as well as primary suffix. Along with root word and primary suffix, they may contain 3 secondary suffix, primary prefix, secondary prefix also. So 2 are must. Each and every organic compound contain 2. Some contain 3, some contain 4, some contain 5 parts. In this structure, each part represents some information regarding organic molecule. Each part. So if you see root word, so when you see root word, each and every organic compound contain root word. What is root word? Root word tells about, root word represent root word represent the number of carbon atoms present in parent chain of given organic molecule whose IUPAC name we have to write. Given organic molecule. Given organic molecule means the molecule whose IUPAC name we have to write. So given organic molecule. Root word represent the number of carbon atoms present in the parent chain. So to understand root word, we must aware of parent chain. What is parent chain? So I am writing definition of parent chain. Parent chain. So what is the parent chain? The longest continuous carbon atoms chain. In given organic molecule. In previous videos I have already explained what is parent chain. Given organic molecule. What is the parent chain? The longest continuous carbon atom chain. The chain that should be longest and that only made up of carbon atom is a given organic molecule. That selected chain is called as parent chain. So the longest continuous carbon atom chain in the given organic molecule is called parent chain. Root word tells about, root word represent the number of carbon atoms present in the parent chain. Suppose if one carbon atom is present, only one carbon atom, there is no question of parent chain. 2 carbon atom, 3 carbon atom, 4 carbon atom. So there is no question of parent chain because there is only one possible chain. If only one possible chain, there is no question of parent chain, then directly we write root word by counting number of carbon atom in that organic molecule. So if only one carbon atom is present, then we use root word meth. If 2 carbon atoms are present, eth. 3 carbon atoms are present, prop. 4 carbon atoms are present, but. Then pent, hex, hept, oct, even regular, all these are regular terms we use. So if 5 pent, 6 hex, hept, so first 4 are different, meth, eth, prop, but. So generally we use for 1 mono, 2 di, 3 tri, 4 tetra. 5 onwards same, penta, hex, hept, oct same. So mono, di, tri, tetra are general terms. Here we get some special root words, special names, special special terms. They are meth, eth, prop, but. So see this. If number of carbon atoms then root word, suitable root word for that. So if number of carbon atoms number of carbon atom is 1, then we write root word meth. Number of carbon atoms are 2, we write root word eth. Number of carbon atoms are 3, we write root word prop. Number of carbon atoms are 4, then we write root word but. If number of carbon atoms are 5, we write root word pent. Continuation. Number of carbon atoms 6, we write root word hex. Number of carbon atoms 7, we write hept. Number of carbon atoms 8, we write root word oct. This is hept, H. Number of carbon atoms 9, we write NON, non. Number of carbon atoms are 10, we write root word dec. 11, for 11 carbon atom we write root word undec. For 12 carbon atom we write root word dodec. For 13 carbon atom tridec. For 13 carbon atom we write tridec. For 14 carbon atom tetradec, like that. For 20 carbon atom we write icosu. Another term is icosu. Use any one, icos or icos. So if 30 carbon atoms are there, then triaccount. In fact, we do not write more than 10 carbon atom. Just for information, triaccount. We use up to this 10, 11, 12. This is enough. But just for knowledge, I am giving like this. For 40, tetracount, not account, tetracount. 50, pentacount, 60, hexacount. 100, hectane, hect means, so like here hect, for 7 hect, this is hect, HECT, hect. So for 1000, million, like that. Okay, these are root words. So what is root word? Root word represents the number of carbon atoms present in the parent chain of given organic molecule. So what is the given organic molecule in the sense? The organic molecule whose IUPAC name we are going to write. Okay. What is the parent chain? The longest continuous carbon atom chain in the given organic molecule will become parent chain. Okay, we select one parent chain, then we count number of carbon atoms in it, and we use a suitable root word among the suitable root word. Okay, so next, after root word, we need to learn primary suffix. So take a screenshot. I am going to rub this. Next, after root word, primary suffix. This primary suffix also each and every organic compound present. In each and every organic compound IUPAC name, primary suffix is present. Primary suffix. Primary suffix denoted with 1 power 0. Primary suffix, or you can write like this, primary suffix. So primary suffix represent the nature of carbon atoms in the parent chain. What is the nature of carbon atom? Saturated and unsaturated. If carbon is sp3 carbon, if all the carbons in the parent chain are sp3 carbon, then nature of carbon is saturated. If carbons are double bonded or triple bonded. Double bonded mean sp2 hybridization. Triple bonded mean sp hybridized carbon. So sp hybridized and sp2 hybridized carbons are unsaturated carbons. sp3 carbon is saturated carbon. Primary suffix represent that nature of carbon atom, whether it is saturated or unsaturated. So what is the primary suffix? It represents the nature of carbon atoms. It represents the nature of carbon atoms present in the parent chain. present in the parent chain, of given organic molecule, parent chain of given organic molecule, So nature of carbon atoms mean nature of carbon atom, two natures, saturated carbon atom, saturated nature, and unsaturated carbon atom. Nature means two, saturated nature, unsaturated nature. Saturated means carbon carbon single bond, unsaturated means carbon carbon double bond or carbon carbon triple bond. These two are unsaturation. So if if carbon is saturated, then we use primary suffix ane. If carbon is unsaturated, sp2 carbon, then we use primary suffix ene. If carbon is triple bonded, then we use primary suffix ine. Ane, ine. This is very simple part of IUPAC name. We can easily write it. Okay, this is about primary suffix. So what is primary suffix? It tells about whether parent chain containing single bonded carbon, all single bonded carbons, or whether it has a double bond or triple bond. Okay, hope you understand. Next, after primary suffix, we have primary root word, primary suffix, then we have primary prefix. Primary prefix. Primary prefix is also very simple part of structure of organic compound, IUPAC structure. It represents cyclic nature of parent chain. It represents cyclic nature of parent chain. Of given organic molecule. So primary prefix tells us that whether the parent chain is cyclic or not. If parent chain is cyclic, then there is a primary prefix for it, cyclo. If parent chain is open chain, it is not cyclic, then there is no primary prefix. Only primary prefix for cyclic compound. For open chain compound, there is no primary prefix. Okay, so if parent chain is cyclic, then primary prefix is cyclo. That's it, cyclo. With this information, with root word, primary suffix, and primary prefix, we can write most of the organic compound names. See this. So example, I am giving example on the basis of root word, primary suffix and primary prefix. So I am writing CH4, complete structural formula, or otherwise you can understand with condensed formula, simple formula, CH4. So how many carbon atoms are here? Only one carbon atom. So use root word meth. And what is primary suffix? Carbon is saturated carbon. So use primary suffix an. For saturated carbon an. Meth plus an. It become methane. So for this one, CH3, single bond CH3. See number of carbon atoms here, 2 carbon atoms. So root word eth plus in between 2 carbon atom in the parent chain single bond. So saturated carbon an, eth plus an, ethane. Ethane. So for this one, try to say IUPAC name. How many carbon? Count number of carbon, 3 carbon atom. And single bond between them. Single bond between carbon atoms. So this is CH3, CH2 and CH3. When you look at the condensed formula, in between carbon atom 2 hydrogens are present. So it is looking like in between 2 carbon atom 2 hydrogen, but that is wrong. So these hydrogens are not in between 2 carbon atom. One hydrogen is above, one hydrogen is below. Okay, to satisfy valency of carbon, that is 4, hydrogens not be between 2 carbon atom. So every time this just understand these 2 hydrogen above and below, like that. So 3 carbon atoms are there. So we use root word prop, and between those 3 carbon atoms single bond. So ane, prop plus ane, propane. Okay. Hope you understood. Next, I am going forward. See this, for this CH2 double bond CH2. There are 2 carbon atoms, so root word eth, and double bond between them. So ene, eth plus ene. But you can write ethene. For ethene, common name is ethylene. Common names are tribal names. These are also important. In organic chemistry, we have to write their names in bracket. Ethylene, H. Ethene, IUPAC name, ethene, common name, ethylene. So if you see this, there are 2 carbon atoms. So root word eth, in between those 2 carbon atom, triple bond. So primary suffix is ine, eth plus ine, ethine. For ethane also there is one tribal name, that is acetylene. We usually write the tribal names in bracket. Remember this. Next, if you see bond line formula of propane, this is bond line formula. In previous video I have explained what is bond line formula. For organic molecule there are 4 different formula. So complete formula, complete structural formula, condensed formula, bond line formula, and 3D formula. So here this is bond line formula. What does it mean? It means there are 3 carbon atoms. For n carbon, in the middle also carbon. So these lines represent carbon-carbon bond. Zigzag lines represent carbon-carbon bonds. There are 2 bonds. Total number of carbons are 3. So prop, 3 carbon atoms. So prop, 2 single bond. Single bond means carbon is saturated. So use primary suffix ane. Prop plus ane, propane. Prop plus ane, propane. So now see this. Here again, how many carbon atom? 3 carbon atom. So root word is same, pro plus what is primary suffix? Here single bond and this is double bond. Two lines represent double bond. When single bond, double bond both are present, when single bond, double bond both are present, then omit single bond, just use prefix for double bond only. So what is prefix here? Prefix will become in. Neglect in, just write only in. When single bond, double bond are present, write prefix for only double bond. Prop plus in, it become what? Propene. For propene also there is common name propylene. Propylene. Okay. Next, if you see this, what is IUPAC name? Count number of carbon atom 4. 1, 2, 3, 4 carbon atom. So what is the root word? But. For 4 carbon atom, root word is but. These zigzag lines represent single bond. So ane. But plus ane, butane. But plus ane, butane. Okay. Right. If we see this one. So here how many carbon atom? 4 carbon atom. So blindly write root word but plus in between those carbon atom, these two are single bond and this is double bond. When double bond is present, write primary suffix in. But plus in, butene. Butene. It is correct some extent but not full, because if I write like this, so how many carbon atoms? 4 carbon atom. So root word will become but, and double bond, whenever double bond is present, we write in. But plus in, butene. That means butene is not the complete name for this molecule or these molecule, because both are butene, but there is a difference. That is what? Double bond appear at this carbon, 1, 2 carbon, or at the left end. Here double bond appearing at the middle of the molecule. That means butene, the name butene not giving complete information regarding this molecule. So to represent the double bond position, we need to give numbers to the carbon atom present in the parent chain. So 1, 2, 3, 4. Here 1, 2, I use a different color. 1, 2, 3, 4. Numbers are getting importance here because the double bond is there. So give number from left to right or right to left, both the ways are correct. Numbering of carbon chain is left to right or right to left, both the ways are correct, but during giving number to the carbon atoms of parent chain, remember that double bonded carbon, triple bonded carbon, functional group carbon, substituted carbons getting lowest possible number. So what is the rule? Numbering of carbon chain done in such a way that double bonded carbon, triple bonded carbon, functional group carbon, substituted carbons getting lowest possible number. By keep remembering this, we need to give number. Okay, here at first carbon, if I give number like this with 1, 2, 3, 4 like this, then double bond present between 3, 4. If I give number from left to right, double bond between 1, 2. So if you give number from left to right, double bond getting 1, 2. If you give number from right to left, double bond between 3, 4. So which is correct? 1, 2 is correct. Whenever double bond present between 1, 2 carbon, say on first carbon. Whenever double bond present between 3, 4, say the least number 3. So it means here double bond at first carbon, if you number the parent chain from right to left, it becomes third carbon. So giving left to right is appropriate method. So What is primary suffix? Primary suffix with position of the double bond. First position, in. Remember, on both the sides of, number and letters are separated by hyphen, numbers are separated by comma. Numbers are separated by hyphen, letters and numbers are separated by hyphen, numbers are separated by comma. Between two numbers there is a comma, between number and letter there is a hyphen. So, but one in, but one in, or you can also write one butene, but one in, or we can write the number one butene, one in front of the but. So, and this is what? Double bond present at second carbon. So, represent the number at which double bond is present on second carbon. Of course, in between 2-3 carbon double bond is present, but say 2. Butene. Butene. Here T is the letter, 2 is the number separated by hyphen, and 2 and E both also separated by hyphen. So butene, you can also write 2-butene. 2-butene. Hope you understood this concept. Next, I am going forward. See this, how many carbon? 1, 2, 3, 4, 5 carbon. So, root word is pent. Plus, what is the primary suffix? Double bond. We need to see the position of double bond also, because we need to give clarity where the double bond is present at second carbon. So, 2 in pent-2-ene. Pent-2-ene or 2-pentene, pent-2-ene or 2-pentene. Okay, so if this one here 1, 2, 3, 4, 5, if you give number like this, that become wrong, because if you give number from right to left, 1, 2, 3, 4, 5, there is a chance to give number for carbon atoms in the parent chain from left to right, right to left, both the chances are present. So if you give number from right to left, your second carbon getting double bond. If you give number from left to right, third carbon getting double bond. Which one is appropriate? Giving number from right to left is appropriate. Sorry, right to left is appropriate. Right to left is appropriate. Then it will become what? Pent, due to presence of 5 carbon atom, pent, double bond present at second carbon, pentene. So pent-2-ene, pent-2-ene. Both are same. This means what? Both are same. Just by writing left to right, right to left, just by rotating molecule by 180, we are getting the same. These two molecules are same. If you write IUPAC name for both the molecule, if IUPAC name is same, that means that the both molecules are same. These two are same. Okay, right. Next, it means both molecules are same. Same molecule. I have written 2 times, same molecule. If double bond present 2 times like this, if double bond present 2 times, then what we do? Count number of carbon atom, 4 carbon atom, so root word but as usual. Double bond is present, so root word is Sorry, primary suffix is -ine. But here double bond two times. So if you give number 1, 2, 3, 4, double bond present at first carbon and third carbon, then what we will do? We have to represent double bond, we have to represent the information, we have to give the information in this molecule double bond present two times. So in two times. So in two times mean if you put 2, this become at second position double bond, not two times. So in these cases, when double bond or triple bond, when substituent or functional group is present more than one time, then use some multiplier prefixes like di, tri, tetra, di, tri, tetra terms are used before the primary prefix. Suppose here double bond is two times, so use diene, diene. If double bond present three times, triene. If double bond present four times, that become tetraene. At which position double bond present? At first position and third position. Numbers are separated by comma, you know. So 1, 3 diene. This become but 1, 3 diene. But 1, 3 diene. Or you can also write like this. So whenever but double bond is present two times, in such cases write 1, 3 in front of root word 1, 3. In this case but become buta. If you write 1, 3 numbers, 1, 3 or any other numbers, position of double bond in front of root word, then but become buta, pent become penta, hex become hexa, like that. So if you write 1, 3 in front of root word but, then but become buta, remaining is same, diene. 1, 3 butadiene. This become 1, 3 butadiene, like this. Right. If you see this, how many carbon atom? Count number of carbon atom: 1, 2, 3, 4, 5, 6, 7, 8 carbon atom. So root word is oct plus double bond present 4 times, number 1, 2, 3, 4, 5, 6, 7, 8. If you give number from right to left, in that case also you get same number. So consider left to right or right to left, both become same. It doesn't make any mistake, any difference. So on first carbon, third carbon, fifth carbon, seventh carbon, 1, 3, 5, 7, totally 4 times double bond, tetraene. Oct 1, 3, 5, 7 tetraene. Or 1, 3, 5, 7 oct become octa, remaining is same, tetraene, octetetraene. Hope you understood. Next, if you see compound like this, if you see compound like this, double bond, triple bond is present. If double bond and single bond is present, forget about single bond, just write prefix for double bond. If single bond, triple bond is present, single bond and triple bond are present, forget about single bond, just write prefix for triple bond. For single bond, double bond, we write prefix for double bond. For single bond, triple bond, we write prefix for triple bond. If double and triple bond both are present, we have to write prefix for both, that is for double bond and also triple bond. So give number, it become a question, give numbering from left to right, right to left, which one is correct? You know, double bond, triple bond both comes under unsaturation, equal priority. But whenever we get equal priority for 2, then we use alphabetical order. We give priority based on alphabetical order. So double bond, if it is double bond, we use the prefix ene, beginning with alphabet E. For triple bond, primary prefix is ine. in beginning with Y. Between E and Y, which one comes first in alphabet? E. So give number from in double bond 1, 2, 3, 4. So in beginning with E, in beginning with Y. So giving number like this. So from double bond getting more priority because for double bond prefix is in. Triple bond prefix is in beginning with Y. So I am giving priority to double bond. In this case, how many carbon atom total? 4 carbon atom. But plus what is root word? In, both are present. At first position in, at third position in. Total, what is the molecule? But 1 in, remove this E, in 3 in. So here but 1 in 3 in. So in, no need to remove, but 1 in 3 in. Okay, this is the IUPAC name of this compound. Hope you understood. I am going forward. A small topic, cyclo. If parent chain is cyclic, then we write primary prefix cyclo. If parent chain is cyclic, then root word is prefixed by cyclo. So few example. If parent chain is like this, then what we do? So while writing notes, make a note. When double or triple bonds present more than one time, then use terms di, tri, tetra. Use suitable terms di, tri, tetra, etc. to denote the number of times